Okay, here's the homework for the 613 review. So this first problem says on isometric dot paper, graph the system of equations below. What shape is the intersection? So the first thing you have to do is figure out where the intercepts are. So I would do 10x equals 30, so x equals 3. 6y equals 30, so y equals 5. And 5z equals 30, so z equals 6. For my first one, my second graph, 6x equals 30, so x is going to equal 5. 15y equals 30, so y equals 2. And then 5z equals 30, so z is going to equal 6. So when you graph it, so I'm going to graph the first one in green. So I get x equals 3, so 1, 2, 3. I'm going to have a dot right here. Y equals 5, 1, 2, 3, 4, 5. And z equals 6, 1, 2, 3, 4, 5, 6 would be up here. Here's what my first plane looks like. Then let's do the second one in red. So I get x equals 5, 1, 2, 3, 4, 5. Y equals 2. Then z also still equals 6. So when the two planes cross, they create a line. It's hard to see, but it's easier to see in like three-dimensional graph. Okay, 36, verify that 2 to the 7th equals 128. So is it true that the log 2 to the 7th equals the log of 128? So we would do 2 times 2 times 2 times 2 times 2 times 2 times 2. So 2 times 2, this is 8 times 8 times 2. So 64 times 2, which is 128. So the answer is yes. And yes, because it's just substitution. Okay. If 24 equals y, is it true that 24 equals the log of y? And the answer is yes. Again, it's just substitution. Problem 38, write the systems of inequalities that would give the graph at right. So first I figure out what their line is. So like the first one, its y-intercept is 0, and it's going up by 1, 1, 2, 3. So it's 1/3 x. So I would have equaled 1/3 x. And it's going to be equal to, because it's a solid line, and it's everything shaded above, so it's greater than. So then the other line, its intercept is 4, so I know it's going to be plus 4. And its slope is 1/1 or 1. And it's going in, so it's negative direction, and we have y, and it's less than, and it's also a solid line, so it's less than or equal to. Simplify each of the following expressions. So for the first one, I'm going to factor. First, I take out an x, and then I have 2x and x. And I'm going to have 1 and 3. That way I get 6 and 1, which is going to give me a positive 5. So I want to be positive 5, so this is where I put my plus and my minus. And then on the bottom, factor out an x. And I'm going to get I'm going to get 2x minus 1 and 2x minus 1. So both the 2x minus 1s cancel, and I have 1 here. So I'm left with x plus 3 over 2x minus 1. And then the next one, these actually all cancel out. So I don't need, oops, sorry. I have to take an x out first. And then they cancel out. So I have to pull an x out of the top of that one, but then I can leave it 3x squared minus 5x. Nope. I've taken x out of the bottom one. So I can leave it 3x squared minus 5x minus 2 times, and the top I'm going to take out an x. So I get x minus 5. The bottom I take out an x, and I leave it 3x squared minus 5x minus 2. And then over here, when I factor, I'm going to get 2x, x, 5 and 3 minus each other. So these 2x minus 5's both cancel. The x's cancel. This whole thing cancels with this, so I'm left with 1 over x minus 3. Problem 40, solve. So in order to solve, the first thing I'm going to do is try to get rid of my square root. So I have 3x plus 1 equals x minus 3. I'm going to square both sides. So I get 3x plus 1 equals, when I square x minus 3, I'm going to get x squared minus 6x plus 9. So then I'm going to move everything over to make it equal to 0. So I'm going to get 0 equals, I'm going to subtract 3x and also subtract 1. So I get x squared minus 9x plus 8. So then I factor, and I get x minus 8 and x minus 1. So I'm going to get x equal to 8 and x equal to 1. So then I should have gotten 2 values for x, which I did, so I don't have to redo the problem. And then did I check both solutions? So I'm going to plug them back in. So first, let's plug back in the 8. So I get 3 times 8 plus 1 square root of minus 8 equals negative 3. So I'm going to get 24 or 25, the square root of 25 minus 8, which is 5 minus 8, which does equal negative 3. So that works. So then I plug back in the 1. So I'm going to get 3 plus 1 minus 1 equals negative 3. So I'm going to get 4, which is 2, minus 1, which is 1. It's not equal to negative 3. So x equals 8 is the only solution. Solve each of the equations. The first one, I'm just going to solve for as it was equal to 0. So I get x equals negative 4 or 5 over 2. For b, I have to factor the second one. So I have x plus 4. And I'm going to have x, 3 and 2 minus minus. So I'm going to get x equals negative 4, positive 3, or positive 2. For c, I get several solutions for x. So x is going to equal 0. It's going to equal negative 1. It's going to equal 7 over 2. It's going to be equal negative 4 over 3, 13, and negative 7. Determine if each of the following functions is odd, even, or neither. So I graph them, and the first one is actually neither. And the second one is even. And solve for x, y, and z. So their exponents are the same, so they have to be equal to each other. So x has to equal 3. So then y equals x minus 2. So I just plug in x. So y equals 3 minus 2, or 1. And then z equals 2x minus 3y. So I do z equals 2 times 3 minus 3 times 1. 6 minus 3, which is 3.